In this section, we will talk about some main physical properties of unknown material which I have observed in my lab at home. There are two ways for increasing the temperature or the light color of the unknown material, either by increasing the electrical power, current or voltage, or by elongating the material with constant electrical power. Option 1 is obvious and we have proved it in previous section as it related to the heating process of unknown material and we saw how voltage affect on that material. Let's talking about the strange property of elongation which I have noticed in my experiments at home. When a conductor touches an unknown material by sufficient electrical power, the material will start glowing. Suppose that glow was in the red color. Now when we move the conductor away by very small distance, the color of glow will change from red to orange due to the elongation of unknown material. It seems to me that there are an electromagnetic force between the unknown material and the conductor which will prevent the separation between them. The unknown material or the conductor may be acted like mechanical spring. Now when we increase the distance of elongation by a little bit, the color of the light will transform to yellow. Definitely, the white color of light must be followed if we are elongated more according to the radiation spectrum of black body curve. But there was an electrical interruption, which means there is no electricity in our circuit due to the air gap. The white color appeared in a part of second only and then vanished.
The proof of what I said has been tested as we saw in this experiment video. We have zoomed the camera to see a single point of light clearly. The red light was being illuminated in the beginning of the experiment firstly. When we increasing the distance between conductors, the light will turn to orange or yellow. After a while, the white color will occur by elongate the material more than previous. Doesn't this glow point disk is similar to the shining of sun or star? As I said previously, camera phone will give a false or deceive color of light, but we can accept it as it's the evidence of changing light color by elongation of unknown material.
Maybe this property is very exciting. As we know, the value of resistance ohm is a quantity measurement for holding off the electrical charge from moving inside the material. Metallic materials such as copper and iron has a low resistance which makes them very effective for using a low voltage. They name it as conductors. Tungsten has very high specific resistance, twice aluminum and less than iron, steel, platinum and lead, with capability of conduction by low voltage, and that makes molecules of tungsten to be vibrated in high motion rate. In addition, the high melting point MP of tungsten is also an advantage, which was 34 to 22 Celsius degree rather than using aluminum which have MP equal to 660 Celsius degree. Organic compounds, plastic material and wood and air has a high resistance value which will prevent current electrical charges from motion freely unless we apply very high voltage on it, more than 1000 voltage. Sometimes this material are called electrical insulator, but actually there is no material in the world that can be insulated 100% if we applied a suitable voltage on it to break down its atomic and molecular bond. What happened in my experiment was very odd. The unknown material has both properties of conduction and insulating. For proving this property, I have used a digital multimeter to measure the current and the resistance.
For measuring current, I have connected two probes of the multimeter device with my system electrical circuit in series, and the voltage of battery, the phone charger, was 3.7 volts. The unknown material has been illuminated after we turn on the circuit. As we see, the value of the current circuit was 0.24 ampere, and that means that value of the resistance by simple calculation will be 15 ohm only. Now let us see what is the multimeter will say when they measure the resistance without battery or phone charger. It wants few seconds to adjust the wires connection correctly. The switch has been moved to ohm meter section in multimeter. Value 1 is an indication that we are not in the proper right selection of ohm meter value suffix, so we should change it until we reach the correct one. Now here it is a value of the resistance. It shows more than 6 mega ohm. This value will be fluctuated for a short time. The initial value of resistance will be reduced for a period of time and then start rising until reach very high resistance. Here it is now the resistance has been increased its value. I think temperature has a direct proportional relationship with the value of resistance unknown material. And when it cool stable condition, the unknown material will act like insulator air. Let's see that the reading of multimeter for resistance section can be assumed as approximately equal to 3 kilo ohm. That's strange, isn't it? Because the current of the system was 240 milliampere, which I turned on the battery of 3.7 volt. But as we recall, the resistance value by ohm was 15 ohm. So why I have the approximation? Why I have an approximation resistance of 3 kilo ohm for a system in a status of inactive in circuit? As we noticed, the readings of multimeter for resistance will keep rising too much until makes no read at all. That means in electrical conception that my system has insulating properties. Let's see what will happen if I turn on the battery of 3.7 immediately. The matter of insulation property, I have checked it many times, and if I was connect two probes quickly, the value of resistance may be reading 400 ohm, and the same behavior will repeat it again by reducing the value and then rise it to higher resistance value. In all situation, what happens is strange with that ohm law.
If you are thinking that heating may have a direct relationship with the expansion of material, and when it is cooled it will be decrease the length of it until reach to original length, or in another word, You said that there were an air gap, and because the distance between unknown material and conductor are very small, so it was happening a gas ionization which lead to expand the unknown material until it contacts the conductor and then let current to pass with illuminating the unknown material. After turning off the system, unknown material has returning back to its original position, which explains why multimeters gives you very high value of resistance air gap. Actually, that was my first thought, but I remembered that I have made another experiment previously indicated that there is no ionization gas process of all by using LED circuit.
In the beginning of, we will start to activate the light of the system by using phone charger 3.7 volt. Then we connect the system circuits with LED bulb in series. As we see, the unknown material has been illuminated with red light inside the hole. Now we connect to the LED circuit. From this experiment, the LED bulb has been illuminated without any sign of light on the system of unknown material.
This experiment indicates clearly that there are threshold or minimum voltage for unknown material to break down the insulation wall to be conductors. This feature is very similar to the diode, transistor, LED parts in the electronic boards, as it has also a threshold for passing electrical charges current after collapsing the gap between the semiconductor material. To make more technical comparison, we will compare unknown material with resistance of incandescent lamp. You see the wire of tungsten is very short and you may think it is 3 cm, but actually the length can be many tens of centimeter of extremely thin wire. The length can be 80 cm. That's happened because we coil very thin wire in the spiral shape with diameter similar to human hair. The table shows some technical parameters for tungsten wire. The specific resistivity of tungsten is 5.6 multiplied by 10 up to minus 8 ohm meter. By assuming that length and radius was 50 cm and 25 cm respectively, by simple calculation we will find that resistance of tungsten will be 14.3 ohm in 25 Celsius degree cold environment. Now suppose that voltage of the national electricity grid is 240 volts. So by using Ohm's law we will find that current will be 60.8 ampere and the power is 39 watt. Definitely there is something wrong because you will not find a tungsten lamp with that value of current or power. So what happened? The science or the lighting companies are lying to the customer by fake advertisement, as it always claims that the power of incandescent lamp is approximately 75 watt, not for 4039 watt. Actually they don't lie on us. The specific resistivity of tungsten has a direct proportional relationship with the temperature, and we know that we should reach temperature of 2500 Kelvin if we want to produce white color or visible light. When they say that the power of the incandescent lamp is 75 watt with the voltage of 240 volt, so the current will be 0.31 ampere, and the resistance of the tungsten is in operating temperature hot environment will be 768 ohm. The molecular vibration of tungsten will be higher in hot temperature than cold temperature, but this unknown material is different totally from the metallic wires, as increasing the temperature has an inverse relationship with the resistance. In cold temperature it acted as insulator, high resistance, and when it turned it on electrically the resistance decreased in hot environment. I think now this property is very clear, and I have talked about mode insulator, which was the material behaves like insulator and the conductor based on the temperature, such as vanadium oxide, VO2, in the last part of this video series. When I was almost finishing from preparing this video, I asked myself question about strange behavior of insulating and the conduction of that material. Does the unknown material has a voltage forward similar to the diode transistor LED or not? Normally diode and LED will have voltage forward more than 1000 millivolt, and we can use multimeter to test our LED to see if it is damaged or not. I have measured my own LED and it gives me a value of 1309 millivolt. Definitely this is an important value which will help us to evaluate the voltage drop when we want to add LED or diode to our electronic circuit board in many applications, especially robots. Now I have did the same thing with that unknown material.
I have turned off the DC battery phone charger from the circuit, and then diode meter has been activated on the multimeter device. I have hidden the second part of multimeter to secure my circuit, which contains the unknown material. In the beginning, the forward voltage will display 580 millivolt on the multimeter screen. Then it will increase after minutes to reach up to 1200 millivolt. The fluctuation of values may indicate that there are many factors effects on our reading, such as temperature, humidity, and air motion. I must mention that if the forward voltage value is less than 400 millivolt, so it means that the current has been passed from the cathode to anode without enter the region or the body of the diode or LED. This situation is named as a short circuit. I think we can accelerate this video now. Anyway, the reading will decrease and increase until we reach no reading as a result of obtaining allowable value or forward voltage in the multimeter device.
These readings has been obtained from another experiment in the same day for the same circuit by this sequence. There was no decreasing at all until we reach high value unless for few seconds. Some purple LED which is operated on 3 volt will not display it on multimeter because it is above the range of the measurement device. So I guess that unknown material will have higher VF than 2000 millivolt. I have tested red LED by another method and gives me a drop voltage of 1.4 volt approximately. Then I repeated the same procedure with circuit of unknown material and the drop of voltage was approximately 5.9 volts for the bright light. We should do a different test to this unknown material, as maybe it has many astonishing properties. One of these tests is that I made it in the homework. If this material has the ability to convert sound to electricity, I put a speaker near the unknown material and the experiment gives negative result. No converting happened. There are a few features related to the unknown material that I have noticed from my experiment in-house. 1. Color. The color of material was ranged between dark brown and black. As you see in this photo, I was able to extract a very small piece of that material after a long time. 2. Smell. When you connect wires to unknown material, you smell something from it. It is not good or bad smell. Accepted without any feelings by harm to your lung. It does not give any white or gray gas color similar to burning wood or carbon. It was a transparent gas. 3. Sound. You hear a clear hissing sound, buzzing noise when you connected electricity with unknown material like that. But the sound has an inverse relationship with the elongation effect, property 1. When I elongate the material, the sound will decrease until you don't hear anything. Consequently, in that moment, the illumination of material will give very bright light, which you cannot imagine. When I thought my phenomenon had a relationship with gas ionization, I was told this a corona discharge, as it has the same buzzing sound, which is found in some electrical towers of high voltage 500 kV. Corona has the ability to generate many harmful gases such as ozone, O3, and nitric oxide, NO, and in turn nitrogen dioxide, NO2, and thus nitric acid, HNO3, if water vapor is present. These gases are corrosive and can degrade and embrittle nearby materials, and are also toxic to humans and the environment. But there was two differences makes me sure that it is not a corona discharge effect. The light of corona discharge is often seen as a polish glow or in the another color in the air, but my light was red, orange, or yellow. Also, as I said previously, there is no gas ionization in my experiment unless it is a combination between gas ionization and heating process of unknown material. 4. Integral unity. One day I was able to extract a tall piece but small of unknown material from two conductors. The diameter of piece was like a single human hair with length of 1 millimeter. When I connected this piece of electricity outside the system, all the piece has been illuminated, and I think it was bright yellow color in that time. 5. Mass conservative. Definitely there is nothing called creating material from nothing. I have seen a reduction in one of the conductor's wire, and I will assume this material has been reacted chemically with some components of air like oxygen, nitrogen, carbon dioxide, and water vapor. After a few minutes I was able to see very small piece of unknown material between two conductors' wires. The mass of piece will increase with time until which I think it will reach to stable status of chemical reaction. I will admit it that the light from unknown material will decrease after minutes, so if it is yellow, it will turn into red until there is no light. Some experiments did that behavior, but the mass of the material has not been changed, so what's happened? I have one scientific explanation related to that behavior, as there were a process which may be called build-up to unknown material on two conductors with that time. And as we know, the outer temperature of material has an inverse relationship with the mass of material when the energy rate electrical power is constant. So increasing the mass will lead to decrease the temperature or color of the visible light. 6. Temperature of light. I have used a digital laser thermometer device to measure the temperature above the surface of metallic material which was subjected to the light of unknown material. The thickness of the metallic material was approximately 0.3 millimeter. When I used battery of 3.7 volts, the temperature was 140 Celsius degree. The color of light in that time was red. Then I have increased the voltage to be 9.7 volt, and the color was yellow. The reading on the thermometer was being recorded temperature of 204 Celsius degree. Definitely we consider the emissivity of the material in our measurements. The photo shows the black body radiation curve for all materials with corresponding temperature and wavelength. Of course, that is not a scientific evidence that illumination of red or yellow or white color can be done by low temperature, which is obvious contradicted with radiation spectrum of black body as we see in this curve, which explains the optimal temperature for each visible light range. There are many factors interfere with our experiment, such as the exposed area, thermal conductivity, and motion status of air, open or closed environment.